4 of them. That makes a total of 6 volts that I've joined together. I've then got a circuit all joined up, and I have a switch over here. The switch is currently in the off position. I can then turn it on, clicking the switch, and we see that the light bulb comes on. If we were to then measure the current around the circuit, we would find that my current is the same at every single point around my circuit. The number of electrons flowing through is the same all around my circuit. If I was to measure my potential difference, the only place I could really measure my potential difference would be across the light bulb to get a good enough reading. If I have 6 volts at the start, as it goes around, I still have 6 volts, 6 volts, 6 volts. I get to this point, and to get across the bulb, I use 6 volts to get across. I have 6 volts here and 0 volts here. My difference across here is 6 volts. Then carries on with 0 volts before it gets back to the cells again, where it then gains the energy again, gains that push again for the electrons of another 6 volts and goes round again. So each electron going through will have a potential difference of 6 volts across the bulb. So that is just a circuit set up. Now I'm going to have a little look at a series circuit. So in a series circuit, all of the components come one after the other. We're still going round, and we will go through here, and we just go one after the other. If I now turn my light bulbs, my circuit on, I see that actually my light bulbs do come on. They both come on. This one here, this first one, is my brighter one, and this one is quite a bit dimmer. As we go through, they would all get dimmer, and if I had more of them, they would get dimmer and dimmer. Again, if I measured my current at every single point around my circuit, I would still find that it would be exactly the same at every single point. Unfortunately, I don't have an ammeter to show you. It is on my to-buy list. Hopefully, I will get one at some point soon. As we go round, we see that the current is the same. Now, my potential difference is slightly different. I still start with 6 volts, and I end with 0 volts. So my potential difference from here to here is 6 volts, but going across both of my light bulbs is 6 volts. However, if I looked at each light bulb individually, so measured it across this light bulb, it wouldn't be 6 volts. And this light bulb, it wouldn't be 6 volts either. It would be split between them. Now we can see that they've got different brightnesses on them, so there's potential that they have a different potential difference across them, or it could just be the bulbs. But the potential difference would be split across these bulbs. Now, a problem with series circuits is that if any of the components along here break, the circuit is no longer working. If, for example, I was to unscrew this light bulb and take it out, the other light bulb goes off because my circuit is now not complete. If I complete the circuit again by putting it back in, we can see the light bulb comes on again. I'm now going to show you a parallel circuit. So a parallel circuit, as the name suggests, the components are parallel to each other. So just like with a parallel lines, they are parallel to each other. Now, at this point, if I turned it on, it wouldn't work. We can see it doesn't work there. If I tried going, oh, well, I'm drawing it across there, still doesn't work because I need to get back onto this part here. I need to get back to the other end of my cells. So I need to add on some more parts. Add on these extra bits. So I now have a circuit that is now all set up and complete. If I turn it on now, we can see that my light bulbs are both pretty much equal brightness along here. Now, when I look at my current going along here, at this point going along here, this first bit before I branched off, I find that I have my current. We could call it 5 amps. On this side over here, coming back, I also have 5 amps where it's branched off. If I was to measure the current along these 2 branches, I would find that it would not be 5 amps. Instead, it would be split between the 2 of them. So I would have 2.5 amps on this branch and 2.5 amps on this branch. So in a parallel circuit, my current gets split between the branches. So if I had a 3rd branch on the end, it would be split between there as well. Now, however, the potential difference, you remember when we did a series circuit, it was split between them. Now I'm in a parallel circuit. If I measured the potential difference across here, I would find that it would be 6 volts still. Likewise, if I measured the potential difference across here, so my other light bulb, it would also be 6 volts. And that is very useful because it means I can have bulbs of the same brightness. It also means that even if one of my light bulbs breaks and disconnects, the other one will still work because I still have a complete circuit going along here. This means that if one bulb breaks or one component breaks, it will still work. If I put it back in again, they will both come back on again. And you should notice that there is no change in the brightness of my other bulb because my potential difference across it has not changed. Thank you very much for watching. I hope this has been useful. Please don't forget to subscribe to the channel. Have a great day. Take care. Bye-bye.